Yeah, hello, good morning, everyone. Yeah, I'm Israel Shoya Words from Technical Grandiose Services Limited. Yeah, yeah, we are continuing from the last video we did on relating to the NDT series. Understand? We talk about on the last video we talk about the general curriculum of NDT, general curriculum of NDT. Sorry, don't mind my trying. And then wipe it out. We spoke about the general curriculum of NDT. Understand of when you talk about the entity fundamental in general, I'll just summarize it that day on the first video on NDT fundamentals. We talk about the purpose of NDT, we talk about the advantage and limitation of NDT, we talk about the comparison of NDT, we talk about the terminology of NDT. Then we'll move on so on and so forth down to the ending of it. So like what I said today, we'll be talking about entity fundamentals in detail. Understand? Please do well, like, share, and also subscribe to this channel. And secondly, I would really like those my guys that contacted me on relating to NDT trainings. Understand? Please do it well to listen and do it well to also ask questions. It's very paramount because one of the key of learning is to ask questions. What you don't ask, you will not know. Understand? You are free to DM me for questions. So questions or things that seems confusing, you are free to DM me to ask questions. So and I also want to use this opportunity to talk to my boss and my madam there. Please, if you have someone that is willing to go through training of on NDT aspects, understand that is willing to learn something new, you can also recommend our channel to that person. Understand? Recommend our channel. Understand? One of the desire I really want us to put on this training is to give attention. Understand? To give your full tenacity on it. Understand? Your full tenacity on it. That is one of the great prize for it. So we dive to the topic we have today. Today we'll be talking about on this part A, NDT fundamentals. This is what we'll be talking about today. We're talking about entity fundamentals. Understand? Oh, like last week, I've already touched all relating to the subject on the entity series. And before, lest I forget, before we continue, I said that if you want this entity series PDF at the end of the entity series, please share this link to at least 10 persons and send me the proof of the 10 persons who send the link. I will also I will forward you this NDT and that on the NDT series. Understand? Please do well. Send the link to everyone. Understand? Those that are interested, not just everyone. Somebody that is interested to learn you something. Understand? You can send the link to them. So, like what I was saying before, that we will talking about entity fundamentals, of which we are going to talk about the purpose or and principle of entity. We are going to talk about the advantage and limitation of entity. We are going to talk about the comparison and terminology of entity. These are the subjects we are going to dive into today. Please do well. Like what I said, do well. Like, share. I also recommend our YouTube channel to others. Please excuse me. I'm trying to wipe this. It's not responding. I don't know what is wrong with the course. So just hold on, hold on. I don't know why this is not responding. Let me see if I can undo it. Okay. Undo should be more preferable. Okay. So please let's do way to tag on. So let's move straight to the topic of today. Enjoy the groove. Hmm? Just keep on enjoying the groove. Please hold on, hold on, hold on, hold on. Okay. Let's rock and roll. Like we're talking about We're talking about what we have today, which is under the NDT fundamentals, purpose and principle of NDT. Purpose and principle of NDT, advantage and limitation of NDT, comparison and different of NDT mentors and terminology. Don't mind my distance. So let's go straight to the topic. Okay, understand the A part of which we already highlighted is what we'll be touching today on the chapter 2 of the entity series. We are going to talk about the purpose and principle of entity, like what you just stated on the timetable. We are going to talk about this one. We are going to talk about the advantage. Then we are going to talk about the comparison and different method. Then we are going to talk about the terminology. Okay, so we are going to visit this picture later on as we progress. We'll come back to that pictures as we progress. Okay, number one, we're talking about the purpose and principle of NDT testing. The purpose and principle of NDT, non-destructive testing. What do you understand? What do you understand by meaning of NDT? What do you understand by the meaning of NDT? Here in our PDF here, we have say NDT means inspecting a material, weight, pipe, tank, or structure without damaging it. This is the whole essence of purpose of NDT. Please excuse me. Hold on, hold on. I just want to do some few time here. So we know I said I don't want us to exceed 30 minutes in this class. So understand. When we talk about NDT, I will use set an example using our normal medical history. I don't know if we have experienced somebody that have broken bone. Understand? You have a broken bone and they said that I want to go, let's go and carry out X-ray checkup. Understand? Reaching there, they will carry out X-ray checkup. Understand? Without even cutting the hand, they already know what the spot that is bad within the bones via the help of the X-ray. What they simply did is NDT. Understand? Meaning you don't have to destroy the material before knowing what is wrong with that material, before knowing that there's a flaw with that material. That is the whole purpose of NDT. So a component can still remain service after inspection. Understand? Meaning the component can still remain in service. You can still make use of the component even after inspection. Understand? Example, when you check a weld in a pressure vessel, checking a pipeline corrosion, checking cracks and steel. Understand? All these are NDT you are doing. You don't have to destroy the pipe. Understand? You don't have to destroy anything, but you already know what is wrong with that pipe via using NDT method. This is why oil and gas power plant fabrication and refineries depend heavily on NDT. Understand? It ascertain the integrity of weight, ascertain the corrosion rate, ascertain the remaining lifespan of that material. Understand? So it's very paramount that before the refinery will be built, NDT must be standby. Before any power plant fabrication or anything related to NDT must be standby. So because it ascertain to know the integrity of the word. I believe you are understanding it. Like what I said, what you don't understand, please do well. Ask question, DM me. So what are the main purpose of NDT? When we talk about NDT, what is the main purpose of NDT? One, main purpose of NDT one is to detect for defects. That is number one purpose of NDT. The reason why the refineries are always applying applying NDT techniques on whatever they are doing on their way everything. One is to detect for defects. Understand? So defects like cracks, porosities, slag inclusion, and corrosion. Understand? That is one of the reasons why they carry out NDT. That is one of the main purpose why they carry NDT. Why number two purpose why they carry out NDT? It to ensure safety, safety of the material and safety of the environment, safety of the persons around. Understand? That is one of the purpose. Understand? Because imagine when you know the issue of when you know how to solve a problem about a particular something. Understand? Even before the scenario will play out, you've already arrested it. Arrest it. Just like for example, if you are having a symptom of malaria, even before before it will escalate. You go to the chemist or you go to any of the pharmacy shop to get drugs for it and immediately arrest it. Same goes to NDT. Understand? Before the thing will get to the worst stage, NDT already verify it for you before now. So one, it prevents leakage, it prevents explosion, it prevents structural failure. Understand? So that it also prevent it protects personnel because the personnel that is working in the field, if they are not aware and there's an explosion, you understand, it's also an hazard already. Why number three purpose of NDT? One, number three purpose of NDT again is to maintain quality control. To maintain quality control. That is number three purpose of NDT. To maintain quality control. Like here, what I wrote here is talking about say he ensures fabricated weight meets code requirements. It ensures fabricated weight meet code requirements. You get understand? Like once welders have done welding their joints, understand, they control the quality of that weld. They ascertain the integrity of that weld to know if that weld is good to go. So you see, it maintain the quality control of every fabricated work, every welded joint. Understand? So it's one of the purpose again is to maintain quality control. Why number four purpose of NDT? One, it extend equipment life. It extend equipment life. It extend equipment life. I don't know if you get, for example, now, when talking extend equipment life, if for a ration I saw a pipe that is already corroding, understand, like the paints they use, the paint they use to paint the pipe is already losing from it. Your ability to see visually, first of all, you already detect a flaw. Understand? You can arrest that corrosion for being up to the maximum height by you going back to paint that particular pipe and to prevent for corrosion. What you simply do now, you've already extended the equipment life. Because, for example, if you leave that pipe, that bell pipe like that, for example, if the pipe is supposed to last for let's say 3 years, that pipe will last like 1 year or 1 year and a half, being that there is no prevention to prevent the corrosion pipe. But with the help of NDT, you can extend the equipment life. That is the number four purpose of NDT. I believe you are understanding it. I believe we are understanding it. So I will recapture it again, talking about the purpose why we carry out NDT. The number one we make mention of, we talk about main purpose. One is to detect for defects. Number two is to ensure safety of the materials. Ensure safety to prevent against leakage, explosion, structural failure. Number number three to maintain quality control. Number four to extend equipment life. Then talking about the basic principle of NDT. Understand what are the basic principle of NDT? The basic principle of NDT. Every NDT method uses a physical energy interaction. Every NDT method use a physical energy interaction. Understand? For that of the visual testing, that of the testing uses light and the human eye. Understand? These are the physical energy interaction. Use light and human eyes. When we talk about ultrasonic testing, it uses the high frequency sound waves. Understand? For that of ultrasonic, use a high frequency sound wave. Then when you talk about radiographic testing, uses S3 and gamma ray. Uses S3 and gamma ray. Then when you talk about magnetic particles testing uses magnetic field leakage. When we talk about penetrance testing, uses capillary action, of which we are going to go in details in the later rounds. We are going to explain more detail about all these principles of NDT, all these NDT methods and their principle. We are going to explain more detail on it. Understand? I believe we are understanding it. Like what I said earlier on, what you don't understand, please do it. Ask questions. Ask questions. DM me, call me, understand, ask questions. And secondly, please do well, don't forget to press the like button, also to share, understand, also to subscribe. So that anytime we post, you can able to know when we post. Please keep in touch. Keep in touch. I believe we are enjoying the global. Are we together? So let's go back to our this thing. So principle demonstration, like what I said, We are going to explain a bit details on those principles. So we are going to explain on the principle demonstration of all the NDT techniques. When you talk about visual inspection, it relies on direct or human observation using light. Understand? This is the principle demonstration. It relies direct on human observation, meaning you see, you observe it, and using light. Understand? You can, but if you are working on that, say you are working on normal daytime, fine. You need the daylight to be able to observe what you are seeing. But if you are working in the night, you need a good light, a good torchlight, a good light for you to see what you are expecting and observing. So these are normal principles. If a light reflects differently, defect is visible. Demonstration of material. When we talk about the things we need for visual inspection, materials needed, we need the torch, inspection lamp, we need the mirror for hidden areas, we need the magnifying lens. Understand? We need all these equipment to aid our visual inspection. So, what is the procedure to carry out visual inspection? Number one procedure before you carry out visual inspection. Understand? What is the procedure to carry out visual inspection? Number one procedure, one, clean the surface of the area you want to inspect. Where most NDT technicians normally get it wrong. They just assume, but you don't assume in the field of NDT. What you do before you go with the right procedure, aligning it with standard and the code of practice. Understand? You first of all you clean that material you want to inspect and all the area you want to carry out the inspection on. You will clean it properly to the bell material, understand, to the base material you want to inspect to enable your heat clean, free it from oil, grease, anything rust, all this thing. You need to clean it well properly. Then number two procedure, you shine your light at an angle. Understand? For example, if I'm standing here, if I'm standing on this spot, I will shine the light at an angle. Understand? To enable me to see what I'm doing properly. Then number three procedure, you observe carefully. You observe carefully. Understand? Here come your expatriate. Here come your understanding of the field. Your ability to see undercut and know it's undercut. Your ability to observe and evaluate flaws. Understand? Is very paramount. Understand? So what happens? Crack corrosion undercut visible directly. You are using light reflection and eye sensitivity. I believe you are understanding it. So that is for aspect of visual inspection. So you must go with this procedure. Don't just dive into doing visual inspection based on say it's not just for me to visualize what I want to do. No, it's not, it's far beyond that. It's not about just going to visualize. You must go with the code of operation. You understand? I believe you are understanding it. Please, what you don't understand, please do well. Understand? DM me, ask me question, call me. Another thing again to also pass the message to us, we also certify on ASNT level 2 in case you want to have a certification on each of these methods on ASNT level 2. We also do certification for personals. We first of all carry out a training. If you are a person that have already experienced in the field, we carry out at least 1 week training. Then, but if you have no experience, at least we carry out to 2 weeks training. Then after then, we'll talk about on how to go on the issuing of the certification with you. You can contact me on that. Understand? Also, if you want the field experience on editing, you can also contact me on it. Please, like what I said, the purpose is to raise skilled men. That is one of the purpose of Technical Grandeur Services Limited is to raise skilled men in the industry. Please do well to contact us on it. And number two, we'll be talking about dye penetrant inspection. We'll be talking about dye penetrant inspection. Dye penetrant inspection. You can call it DPI or PT. All these acronyms. Please don't get carried away. This never happened some years back when somebody went for went for an interview. They asked him what is different between DPR and PT. The person was confused. But what the guy was simply asking him is the same thing. Understand? But yours and different acronym. Understand? Penetrant testing or the penetrant inspection. He's saying the same thing. Understand? So please, you got to be familiar with one thing. You got to also be familiar with. You need to be familiar with the acronyms of NDT. That is DPI, PT. You got to be familiar with these acronyms. It's very paramount. That is for that. So talking about the penetrant inspection, the principle. This principle of dipenetrant inspection is based on capillary action. I don't know if you understand capillary action. Liquid penetrant small surface opening. Okay, let me set an example of talking about capillary action. I, how many of you those that have bought a keg of kerosene and there's a water drop on that kerosene? You will see that water will go down beneath the kerosene. You see the water at the bottom of the gallon. Understand? You see the water at the bottom of the gallon while the kerosene will be on top. What simply happened there is capillary action. The rise and fall of liquid. That is another example to understand. So and that is one of the example. That is the easy example my hand can touch for the now. Understand? So what happened there is capillary action. Understand? So the same thing is being applied when we are inspecting on welded joints. Understand? Demonstrations. What are the material we need? Like what just know that happen in visual inspection. It also goes materials we need. We need a cleaner. We need the penetrant, which is also known as the dye, red penetrant. Also, we need the developer. Okay, the cleaner, what is the purpose of the cleaner? The cleaner, it cleans the surface of the material you want to inspect to enable visibility. That is one. When you talk about the penetrant is just like the dye. How will I call the penetrant? I'll call the penetrant the kerosene, just like the example I cite, using when you buy a keg of kerosene and there's water drop inside that kerosene. That water will go, I be beneath or be upward. I don't really, but it will go down whereabouts. I believe so. Understand? Then the kerosene will build up. That two separation between these two liquid is known as capillary action. The same thing is being applied. The dye is just like a kerosene. Then the developer, which is stand as water, goes down. See the basic principle of how it works. For example, if I want to inspect a material on DPI, what first of all do I clean the surface I want to inspect, the area I want to inspect, then I apply the penetrant testing on that area. I leave it for a time from some time, which is normally called the dwell time. I can if the weather is good, understand if the weather is so sunny, I can leave it like 10 to 15 minutes. The reason why I'm leaving that red penetrant to enable time for that red penetrant to penetrate into those tight cracks on the welded joint or on the plates you want to carry out inspection on. To enable the red penetrant to penetrate into those tight cracks. After the wait time of 15 minutes, you pick your cleaner, you spray on your rag, you wipe the excess penetration from the surface. Just clean the surface properly. Then what you do next, you apply developer. Here come developer. Developer is just like that water in the inside the kerosene gallon. You put the developer at those spots. What the developer will do, it will sink in and bring out the red penetrant. The developer will sink in into the crack, then it will bring out the red penetrant. That red penetrant will bring, you will see the indication of the red penetrant on the weld. That will indicate if there is a crack or if there is something like flaws on it, it will indicate it that because the red penetrant will come up, then the developer will go down. Also, the developer also stands for magnifying the penetrant, the red penetrant. Understand? You will see the line of the red on the weather joint. I don't know if I explained in details. Like what I said, if you want the field experience, you can simply contact me. Then, at least we'll be going to fields together on it, and you can simply contact me on that. When talking about the procedure, I just explained the procedure. First of all, you clean the surface, you apply the penetrant weight, which is that weight is like 10 to 15 minutes if this is sunny. Then remove excess, then you apply your developer, just like what I explained in arrow. So no need for us to waste much time. Believe you grabs, like what you don't grasp, you can simply ask question or call me via WhatsApp or DM me. Why? What happened? That enter crack, like what I explained earlier on. Develop pull it at. I don't know if you can like how I explained now. Understand? The die we enter the crack. We enter those tight corner. Then what developer do? Developer will pull them hard. That is what normally happen. So red indication in white background, like what I just explained earlier on. I believe we are understanding it. What you don't understand, please do well. Ask question. Please excuse me, I just want to look there. Like what I said, I don't want this our class to be more than 30 minutes. Let me just try to fasten up because we are already editing 30 minutes. So number three of the NDT method, we'll be talking about magnetic particles inspection. We're talking about magnetic particles inspection. Understand what is the principle based on magnetic flows, magnetic field leakage at defects. Understand what happened? I don't know if this is if you've played with a magnet bar Understand? Because of you playing, some particles from the ground will be coming that magnet bar. What is simply happening there is a magnetic field happening there. Understand? But the scenario is the case is this that wherever there is a crack or there is a flaw or there is a breakage, understand? All the magnetic particles we gather on that particular spot, just as we have in the data PI, the area of flaws, the area where we have discontinuities, all the magnetic particles we gather there, which indicates an indication. If it's a kind of a snake type indication, you already know that it's a crack developing there. Understand? It indicates indication. All the places that we have consigned, the flaws will go to that direction. I don't know if you get understand that magnetic particle will go to that direction. So what are the materials needed? We need the what are the materials needed to carry this inspection? We need the we need the yoke, or you call it permanent. We also need the yoke. We need permanent magnet. Understand? Then we need a magnetic particles. Then we need a state sample. I don't know if you get understand. These are the material we need on NPI. So procedure. First of all, you magnetize, which is magnetize 90-degree magnetization. Understand? You magnetize. Then you apply particles. Understand? You magnetize material using yoke. Then after then, you put on your white background. Understand? You put on your white background to enable visibility. Then you apply your magnetic particles. Sorry, I didn't indicate it here. Maybe later on I will correct it. Understand? You apply your white background to enable you to see what you are expecting. Your white background. Then you put your magnetic particles. Then you start moving your magnets 90-degree and 45-degree movement. Understand? 90-degree, 45-degree, 90-degree, 45-degree movement. That's what you will do on it. What happened? No defect, uniform feed, crack leakage feed, particles gather at different visible line. Ultrasonic testing principle. So number four of the NDT method we'll be talking about ultrasonic. Like what I said, I just want to I will rush in fast for us enable us to cover this section for the section A of the curriculum. As well, we already of please do anything you don't understand. You can watch over and over again at the same time. Also, you can watch it YouTube over and over, or you download it from YouTube. Watch it over and over and get to comprehend. And what you don't understand, you can contact me via DM. Understand? So, based on sound wave reflection, high frequency sounds travel through material and reflect back from defects. Demonstration. The material needed to carry out ultrasonic testing, we need the UT machine. We need the probe transducer, probe also known as transducer. We need the couplant here to seal sand from losing sand. Understand? Is a sealer of sand. The couplant is a sealer of sand. Understand? The probe is used for scanning. Okay, let me set an example. Just as I don't know if your wife is pregnant, you will normally tell you that please, please, I want to go and carry scan. Understand? That the same scan they carry in the medical field is me also apply some but just that is the medical field aspect of it. Understand? It's just somehow similar. Understand? You start scanning for that's the same thing they use. It's also known as transducer probe to scan. Understand? So the same thing kind of vice versa in that of the NDT industrial feed. Understand? You use probe. So procedure, you apply gel on the surface area you want to inspect. Understand? Then you place your probe on that particular on top of the gel or the complant. You start scanning, you start sending wave to it. And many of us have been in an empty room. When you will share, for example, the room will revert the A back to you. What is simply happening there is ultrasonic. When you send wave, the wave will come back, will reflect back. But in the course of this ultrasonic, when you send the wave inside the pipe or inside the weather joint, it will reflect back on the cathode ray tube, which is the screen we use to monitor if there is a flow. And A scan wave will be displayed. So here comes the NDT technician to evaluate those A scan wave to detect if it's a flaw. I don't know if you get. So what happens? Sound travel inside. What happened? Sound travel inside and it defects on backward, then reflect back and return echo, just as you have your voice when you say A in an empty room, the A return back to you. Understand? The same thing happen there when we endorse the A to the into our pipe, the pipe will reflect back. If there is a flaw that in that reflection back, then you will see it on your cathode ray tube. Hope we are understanding it. Like what I said, I will be summarizing it for faster for us to be able to meet up with the time. I don't want this our class to move in more than 30 to 35, 40 minutes. So please, will bear with me. Like what I said, what you don't understand, please contact me on it. I will answer your question. What you see, one echo, no defect, extra echo defect present. Simple analogy like shouting in the tunnel. Yeah, echo like the example I make mention of. Understand? So number five of the radiograph NDT techniques. Number five of it, we will be talking about radiography testing. Radiographic testing, also normally known as RT. Like what I said, please, we should learn to be familiar with acronyms. Understand? In this our industry, yeah, it must be used to acronyms because it helps a lot. Understand? Please hold on. Okay, it helps a lot. So, what the principle is based on radiation assumption. Is based on radiation absorption differences. That is the principle. Understand? When you talk about the principle of radiographic testing, it's based on radiation absorption differences. For example, some parts of the material welded, the area that is being welded, will be more transparent than the area that is not welded. Understand? If I want to carry out, for example, an ROT on the welded joint, that area, the welded joint I want to carry ROT on, that line will be more transparent because you have a thicker material. Understand? Then their area that is not welded, which is the pipe body itself, the parent pipe itself, is a bit darker than the welded joint. Reason being that what is happening there is radiation differences. Understand? One pipe is thicker, so that place that is thicker, it takes a lot of radiation to even make it back. So that's why that place is transparent. Why the parent matter is thicker. The same thing, at that place, at that welded joint, understand that welded joint here that is transparent. There comes where you find your flaws, the area that is concerned. That transparent place now of that welded joint, now you start looking for a darker spot on that welded joint, that transparent place. Now, if you see a dark spot, like example, you can see lack of penetration with a line, a thin line, like some lack of fixture, body, all those things. If you see discover all those things, what happened there? You can easily evaluate it that this place is darker, meaning there should be something here that is wrong with that particular spot. I don't know if you get the same thing is being applied. Understand? So you got to, like what I say, if you want to experience the field experience, contact me. Understand? We'll be going on field experience on it too. Just contact me, do where to contact me. And if you want an ASNT level 2 certification, also do where contact me. So what are the demonstrations? Let's talk about demonstration to summarize it up. Radiation source. What we need radiation source. Our source of radiation. Just example, we need the region 192. We have the combat system, but we don't normally use combat system based on the hazard associated to capacity. The intensity of that radiation is too high. So what we mainly use in the industry is radium 192. Understand? And also we use the normal S3 electrical type of to generate radiation. So what we also need again, we need the film or digital detector. We call it radiographic film. Understand? Then we have the test object, the objects to be inspected. I don't know if you understand. So what are the procedure? Place the source on one side, then place film on opposite side, then you expose. And this is just a summarization of a procedure. Like what I said, you need the framework. All like what we are organizing now is the historical aspect of NDTs, NDT. So from there we'll move to hydro test, historical aspect of hydro test, cathodic protection, and so far. So but for now we are in the NDT series in the theoretical aspect. If you want the practical aspect, please do it also contact us on it. What happened? Dense area absorbed more radiation. Defect, like what I explained on defect, avoid crack, allow more radiation. Film show dark light contrast. What you see, dark spot, void of porosity, clear area, solid material. Sorry, I will and the orange up. So complete comparison table between these NDT methods. Understand? Please, these are the basic NDT methods. It's not limited to these methods. We have different advanced NDT. Please note, but these are the merely basic NDT methods we'll be touching about, which is the visual testing, penetrant inspection, magnetic particles inspection, ultrasonic testing, and radiographic testing. Please take note. It's not limited to this thing. So when we talk about methods, the comparison, visual testing deal with light reflection, then detect visible defects, material or material, and it can be just for surface. The depth is just for surface. Why the penetrant inspection? They work with the law of capillary action, like what we explained. Surface crack or material, and so just for surface. Why magnetic particles inspection? cracks, understand, it only works on ferromagnetic material, meaning material that can magnetize. Of course, we are going to talk it in the next chapter where about on type of material. Understand, have anything on surface plus near defect like 1 mm. Then we have the UT, which work with sound deflection. Internal is mainly used for internal shake. The ROT, radiation absorption, internal shake too. So these are the comparison table. Like what I said, if you want this PDF at the end of the class of the NDT series, please do well. Send our link to 10% and send me the proof of the link you sent to that 10%. I will forward this PDF for you. Are we together? So easy way to remember. One, visual inspection deal with eyes. The easy way to remember on this NDT method. Visual inspection deal with eye. That penetrates liquid enter crack. Then MPI, magnetic release crack. UT, ultrasonic bounce back, sound bounce back. Then ROT, radiation passes through walls to film. Are we together? So we are moving to the next section on the on the it's already 29 minutes. God help us. Moving to the next section of the today's series. Understand? We're talking about advantage and limitation of NDT. What are the advantage and limitation of NDT? When we talk about everything, you have advantage and limitation, right? So, what are the advantage of NDT? Number one advantage of NDT: non-destructive of components, no destruction of components. You don't destroy the component before you know what is wrong with it. The component can still remain usable. Understand? You don't have to destroy it. That is one of the advantage of NDT. Another advantage of NDT is save money. Understand? Like what I said, you don't need to destroy your material even before you know what is wrong with it. Why another advantage of NDT, early defect detection. Early defect detection. That is number three. The other one, they can inspect during service. At the cost of you doing your work, you can still carry out inspection on some many cases. Understand? So improve safety, and again also fast for industrial inspection. It's fast for industrial inspection. I believe you are grabbing it. So that are the advantage of NDT. What are these limitations of NDT? No single method. One of the limitation, no single method detects all defect. NDT is not one drug cure it all. See all these different the various techniques we make mention of, talking about the visual testing, magnetic particles inspection, dipenetrance inspection, ultrasonic testing, and that of radiographic testing. All these methods did this different job. Understand? So it's not no single method detect all defect. Why? Number two, skill operator required. That is one of the limitation. Not be everybody just go do anything. Understand? You must have the skill operation knowledge of what you are doing, the skill know-how of what you are doing. That is number two limitation. Surface condition affects results. Like what I explained, you can't just go there and just start doing editing. No. You clean, you follow the procedure. So surface condition affects NDT results. Some method is expensive, like that of the ROT and UT. So they are more expensive than visual inspection, than magnetic particle inspection. They are more expensive than it. Why we have access limitation. Understand? Also, access limitation can also be a limitation on NDT. So comparison of different NDT, like what we explained, visual inspection for surface defects, quick. The comparison I was talking about visual inspection, surface defect, quick inspection, only visible to defect. Penetrant testing, open surface crack, no porous metals, surface only. Magnetic particles testing, surface and near surface, which is subsurface, ferromagnetic material only, space and steel only. Ultrasonic testing, internal defect, thick webs, speed setup needed. ROT, internal image, wet volumetric defect, radiation hazard. Understand? So these are the comparison of different NDT method. So simple industrial understanding of NDT method. What are the simple industrial understanding of this NDT method? Visual testing, first inspection method before all others. The visual inspection comes before any other inspection. The visual inspection comes first. Then penetrant testing, good for fine cracks or stainless steel. Then we have the magnetic testing. Understand? We have it's best for surface crack and carbon steel. Simple industrial understanding of NDT methods. Then UT best for thickness and internal cracks. Then ROT best for wet internal image. So the number four topic on today's timetable on the curriculum on the fundamental of NDT is terminology, where people get it wrong. You as an NDT technician don't talk. NDT technician must not talk as a doctor. NDT technician must not talk as a furnishing personnel. Understand? We have our terms. You must be familiar with the terms as an NDT technician in the field. Every field one find itself, there's always a thing that governs normal words, normal terms used. So we are going to talk about the terminology and definition of those terminology. When we talk about discontinuity, is one of the things. You watch me at the course of teaching, I make mention of discontinuity, right? These are the terms. What is discontinuity? Any interruption in material structure, any interruption, anything that stands as an obstruction understand the material structure is known as discontinuity. It's not yet a defect because it becomes a defect when you assess it with the code of operation. For example, you can see a discontinuity of 25 mm or 26 mm. You can't call it a defect yet. Then except until you judge it, subject it to the code of operation. Then when the code says that empty lack of penetration, for example, if it's above 25 mm, understand, is rejectable. Already, you already have 26 mm of that flow. So it's already rejectable. It become a defect based on standard already judge it. Understand? The same thing is being applied. Example, poor cracks, inclusion, all these are discontinuity. Are we together? I believe we are grasp understanding the class. I believe we are understanding the class. Also, another terminology we talk about is known as defect, like what I explained. That discontinuity becomes a defect where it's been subjected to code of operation. Let's just go to the definition. A discontinuity that exceeds code acceptance, just like what I explained. A discontinuity that exceeds a code of acceptance is known as defect, meaning not every discontinuity is rejectable, like what I explained. So number three of terminology, we're talking about indication. What is indication? Indication is what you detect. Just like the doctor, when you detect that you are feverish, what is already an indication. Why is you are feverish? There's an indication of feverish there that make it the same thing that will signal or visible evidence during inspection. It's known as indication. That is for doctor terms. These are our terminology. When we see a flaws, we say, this indication. What is the indication? Say, oh, what we saw, the indication we saw was lack of inclusion, or the indication we saw was a lack of penetration. All these are indications. I don't know if you get. They find this is not as indications. So the UT echo, they're just like a voice you will when you're in empty room and say, "Oh, it return back to you." Oh, understand? That is indication. Understand? And magnetic particles line is indication. Red line is indication. So what number five terms again? Terminology. Talking about terminology, acceptance criteria. These are the other words we also make use in the industry. That every entity personnel must be familiar with acceptance criteria. Like acceptance criteria, this is the code that decides either to be accept that flow or to reject the flow. It's known as acceptance criteria. It's a code that will decide if to accept or to reject the flow. I don't know if we get understand. This is the code of operation. So, example, we have the American Society of Mechanical Engineering. We have the American Society of Mechanical Engineering. Sorry, American Society of Mechanical Engineering. Then we have the American Petroleum Institute standard. All these are code of operation. Understand? Then on that term again, we'll talk about sensitivity. Sensitivity. These are other term you as an entity personnel you will experience in the field as you are going. Ability of methods to detect small defects is not sensitivity. The ability of that method you want to imply if the UT, NPI, DPI, ROT, visual testing, the ability for that method for it to detect small defect is known as sensitivity. When we say how sensitive is the defect, meaning how small is that defect. Understand? Are we together? Talking about calibration. These are the terms we are going to be used. Calibration, adjusting equipment with reference standard before use. Understand? Like your monitor, you need to calibrate it up to date. Understand? These are the terms. False indication. false indication. These are indications that are not true. That just false, just give you false indication. Signal that look like defect, but it's not a defect. It look like it. It's not as false indication relating to terms. For example, rough surface, dates, and geometry reflection. So on the training note, what you to take as your take home. Industrial on the training note, from what is we're about to end up the class. On the training note, industrial entity always follow this sequence. One, this is the sequence you follow. You detect, you interpret, you evaluate, then you give report. First of all, you detect the indication, then you interpret that indication. Understand? Then you evaluate that indication with the code of operation if it's acceptable or not. Then you give report if it's rejectable. Understand? These are the normal operation. So with this, we are done with the first curriculum on the A part of the NDT series. I believe you understand. And what you don't understand, please do well. DM me, ask me the question. And also, please, like those persons that really want to learn the skill, that are passionate to learn something new, to my boss, to my guy, if you have that your brother, that your sister that is willing to learn something new, the best way you can give to him is to give him to teach him how to catch fish by himself. You can also contact me or send my number to the person to contact me on the aspect of training on NDT. Understand? So the next class will be holding and the next number topic will be going on the curriculum is material and manufacturing basics. We're going to talk about this material because you got to understand the material you're working with. So it's very paramount. So with this, we call for the class. Thank you very much for your time. To my boss, to everybody on board today, I deeply appreciate. Understand like what we said. At least we are still 30 minutes. At least we are looking at 40 to 45 minutes on this class. But do well. Go to our YouTube channel, download it, watch over and over. Understand? Please like, share, and God bless you. Good day.